Good afternoon. Before we begin, I'd like to introduce the team members who will be presenting today. So, for myself, Manohar, we have Gaurav Pradhan, Sanjana N. Patel, H. Neha, and Mohammad Kamruddin in our team. So, today I'm going to talk about a system which combines technology with environmental monitoring. The LoRa-based environmental monitoring system uses IoT, that is Internet of Things, and long-range communication (LoRa) to collect real-time data such as air quality, temperature, and humidity. This system enables long-distance communication, enables efficient monitoring without requiring constant manual effort. By doing so, we promote faster and faster decision-making ability, which is valuable in various fields like agriculture, industries, and in medical fields. So, in the next slide, we have the problem statement. The current methods for monitoring the environment have some big challenges. They're often expensive, they don't work well in remote areas, and also have poor connectivity. This limits how effectively we can address like fluctuations in air quality, temperature, and humidity, which impacts everyone, whether be it the public health or agriculture or even industries. A LoRa-based system offers a solution to these challenges. It's mainly cost effective, it's user efficient, and also works in areas with low connectivity as well. This makes it a practical choice for tackling these environmental issues. So, moving forward, Sanjana will be it.
Hello, myself Sanjana, and I'll be doing the slides relevance, objective and aims, and the methodology. So, in the relevance, so what is relevance is mainly based on the academic relevance and the practical relevance of the LoRa-based technology and environmental monitoring system. So, this project brings together the cutting-edge technologies like LoRa, long-range communication, and IoT with the critical field of the environmental science integrated within it. So, what it provides is an excellent platform for the students and the researchers to explore how the technology can solve real life problems. So, by addressing these environmental challenges, this project promotes interdisciplinary innovation enabling participants to work across multiple domains. So what is the so next is the what is the practical relevance of this? So in practicality, the environmental monitoring system it is necessary for the growing necessity for industries, governments, and the researchers. So the proposed system can benefit a wide range of application. Basically, the main are the industry air quality control fields and agriculture and urban areas. So in the industrial air quality controls, they monitor the pollutants in the manufacturing facilities to comply with the regulations. And it helps in the agriculture field. It helps by tracking the temperature, the humidity to maintain the optimal conditions for the crop health. So in the urban area, they assist the cities in managing air quality to make sure that the living conditions are more healthier. And they help in by providing real-time and accurate and reliable data. The system also ensures the informed decision making across these critical sectors. And the next slide is the objective and aims. So the main objective of this project is to develop a LoRa-based environment monitoring system system and this system will basically collect the environmental data in the real time like the air quality, temperature, and humidity, and they transmit these data along the long distance efficiently using LoRa. They also another objective is to operate them on the minimal power consumption, and they make sure that it is suitable for both remote and rural areas. And they provide a user-friendly interface, through which we can have now actionable insights. And there are four specific aims for it, basically named as automation, real-time monitoring, scalability, and user accessibility. So automation. So in the automation, it is to develop a system that automates the collection of data and transmission of this data across the long distance and eliminates the need for any manual intervention. And the scalability. Scalability is to create a flexible system that can easily integrate traditional sensors with or they cover larger areas. And the third one is the real-time monitoring. So in this, they enable the real-time isolation for both the data, and they also provide the alerts for any quick responses during any critical changes in the environment. And user accessibility. So it designs an intuitive interface for the users, which helps them to have an easy access to the live and historical data for analysis and decision making. The next slide is the methodology. So in this, the first step is to selection of the components. In this, the system should rely on carefully chosen components to ensure the accuracy and reliability. So some of these sensors are depends on why you need them. So like MQ135 sensor, it is used to measure the air quality by detecting gases like CO2 and ammonia. And the next is DHT22 sensor. These helps in monitoring the temperature and humidity and which are essential for agriculture and environmental tracking. And just like this another one which is LoRa transceiver. So this one helps in long range data transmission, while also they maintain a low power consumption. And the other one is the and the second one is the ESP32 or Arduino microcontroller. It acts as a processing unit to gather the data among the sensor and communicate with the LoRa module. And the system 2 is the integration of the system. So in this, the sensors which are connected to the microcontroller has to capture the environmental parameters, and the LoRa transmitter is to set up to send this data to a LoRa gateway, which acts as a receiver and forwards the data for processing. And the step 3 is data transmission. So in this, it setups in a LoRa modules and configures the transmit data security and relies over a long distance. And it also ensures the coverage even in the remote areas where traditional communication technologies might fail. Step 4 is data visualization. So in this, user-friendly dashboard is to be created, which could be either local or cloud-based, and it is developed to display the real-time data environment and the historical trends and patterns for the deeper analysis depending upon the locations where it is used. And this dashboard also includes alerts to notify users about critical changes in environmental conditions. Step 5 is Step 5 is testing and validation. So the system is to rigorously have to test any various environment to validate their performance. For example, like in the farms, it has to access the long distance transmission and reliability in rural conditions. And the other one is urban areas. So it has to check the data accuracy amidst the potential signal interferences. And in industrial sites, it has to evaluate the sensor accuracy due to the air quality levels. There will be different levels of air quality, so it has to evaluate the sensor accuracy in these places. And the next slides will be taken over by my friend.
Okay, so I'll be doing the slides that contain the code and the output part. So I'll show you the code in the pie chart. Okay, so first I will explain the code. In the first line, we are importing my matplotlib library along with the pyplot module, which is part of matplot library. We are importing the random module, which will be used to generate random numbers to give a real-time simulation of what we can do. Next is used to import the time module, which will be used to fetch the current time, the current real-world time. Next, we create three functions by the name get air quality, get temperature, and humidity. Okay, so in this, we are basically using random module that we imported here, and to generate the values between 50 to 150, and we'll be having two decimal places. This will be used to simulate the air quality index in the values AQI as a unit. Next one is get temperature. Here we are using again the same module to generate random values between 50 to 35 with two values. It will be generated in degrees Celsius. Next we are using the same module to generate values between 30 to 90 with two decimal places, and this part will be used to generate the humidity in percentage. Next we are using the plt.ion. This will be used to make the interactive mode turn on. Next, we have fig, which refers to figure, and ax refers to the access points. So here what we are trying to do is we are trying to create three tables within one single interactive board to visualize three different parameters, these three. So this basically represents the size of each individual table within the interactive board. Now here we are making 4 lists: timestamps, AQR data, temp data, humidity data, to generate all the values that will be generated here. Next, we are using a for loop, which will be running for 50 times because we want to show the output 50 times to make a graph in the table. Next, this line is used to fetch the current time in the format hours, minutes, and seconds. Here, we are basically calling the function that we made here. Then, whatever values we get there will be appended into the values into the methods that are mentioned within the brackets. Next, again, you're using a for loop. Here, basically, all